Yeah, welcome to the last class on this series, at least for now. Yeah, I'm happy. Oh, the same outfit. Oh, sorry. The thing is, not that I have just one outfit though, it's just that I'm recording all of these classes on the same night. All right, so let's get to business. And you might maybe send me some cash to get some outfits if you feel like I should get some more. But really, it's because I'm kind of thinking you might be wondering like how come all these videos have been seeing the same clothes. So it's not that. It's basically because I have to record these classes on the same night. Immediately after the other, starting from calculus of variation up to this particular point. Now let's get back to this particular class, which should be the last. Here it's still under free endpoint, but you can see, or you've probably not noticed. So look at it. Your constraint is not a single uh, number, like it's more than a single number now. So now you have a constant to your constraint. So 24y plus 14. So what do we do? So obviously we are still going to apply the transvertility condition, but we are not there yet. So the first thing is for us to set up um, this guy. So we have a minus 6y squared. We have Hamiltonian plus 2x plus 36y plus lambda into brackets 24y plus 14. Yeah, so let's get to business. The first thing, the h, I just find this stuff interesting, by the way. So we have minus 12y, so you have a plus 36, yeah, then plus 24 lambda equals to 0. So minus 12y equals to minus 24 lambda minus 36. You can just divide all through by minus 12. When we divide all through by minus 12, we have y equals 2 lambda um, plus 3. So equation 1, equation 2. So the next thing is to find so the h, the x, which is going to give us lambda. So minus the h, the x, 2 minus 2. Is there x again? No. So the next one minus the h, the lambda, which will give us no minus is 9. The h, the lambda, 24y is equation 3, 24y plus 14, equation 4. So what are we gonna do from here? Okay, so we substitute equation 2 into equation 4. Equation 2 into equation 4. So x equals 24 into bracket y, all of this, 2 lambda plus 3. Don't forget plus 14. So x dot dot 24 is 48 lambda plus 72. 72 plus 14, that's 86. 86, alright? So this is equation 5. Now let me cross check. 40 lambda plus. Okay. So the next thing is this lambda guy. We have to get just lambda out. So this is integral t, which is integral minus 2 dt. This is minus 2t plus c1 6. So we substitute equation 6 in equation 5. Alright, so um x equals 48 to bracket um lambda into 40, yeah, lambda is minus 2t plus c1. Okay, then we have plus 86. Okay, So we have minus 96t plus 48c1 plus 86. That's 60. Okay, that's that. So now the next thing is for us to get x. So x equals integral xt plus integral all of this, right? Minus 96t plus 48 c1 plus 86 dt. So from there, x gonna just jump into what the answer should be. Minus 48 t squared plus 48 t c1 plus 86t plus c2. That's what should be having. Okay. Now when x is 0, so I can just write this guy as x equals minus, so x0 equals no 5. So we have minus 48 into bracket 0 squared plus 48 into bracket 0 t plus 86 into bracket 0 plus c2 is 5. So obviously c2 is 5. Now apply the transvertility condition. So instead of having x3, so we have a lambda 3 equals 0. So lambda 3 equals minus 2 into bracket 3 plus c1 equals 0. So c1 equals 6. So you can see it's hard at all. So our state variable xt is finally equal to minus 48 t squared plus 48 t c1 to bracket 6 plus 86 t plus c2 5. So we have minus 48 t squared plus 48 times 6 is like 24 times 12. 240, maybe 288. That should be 288. Is it? Okay, 288t plus 86t plus 5. So you can add these two. Minus 48t squared plus 4 16 17 374t. I just hope that's right. All right, plus 5. So these are our states variable. Oh, right. Then so we look for our co-state variable, okay, which is minus 2t. So we have minus 2t plus c1 6. So this stuff is pretty simple. Nope. Co-state variable. I guess I'm just excited to like end this class. I'm kind of tired. Okay, and control variable is it used to have a relationship with lambda. Where is the y? Where's that y guy? Y? Where are you? So y equals 2 lambda. So we have 2 lambda minus 2t plus 6 right? Plus 3. So we have minus 40 plus 12 plus 3 minus 40 plus 15. Hmm. Is it 3? Minus 2t plus 6. Is that our lambda? Lambda is minus 2t plus 6. How? Pi is 2 pi plus 3. Okay, yeah, that's right. So minus 2t plus 6, then plus 6. Is it plus 6 pi t plus 3? Okay, so I was the one who did a mistake in my notes. Plus 3. Okay, so 15. These are schedule. These are true. It's funny that we are calling an entire equation a variable, but it is what it is. Mathematics can be very, very fun. So the slope of the control variable minus 4, the slope of the um, constant variable minus 2, the slope of the state variable is going to be minus 96t plus 374. Minus 96t plus 374. So that's the x dt. Okay, from this point, if you have any question, please um, ask them in the comment section, or if you are still operating the way we used to operate, because at this time in 2022, so that means you have to reach out to me my DM and submit the assignment to me or to whoever the tutor is at that particular period in time. So assignment, you have to maximize uh, so you have 3 0 2x plus 18y minus 3y squared plus 18y minus 3y squared dt. Okay, so subject to x equals 12y plus 7, and your endpoints x0 equals 5, x3 is free. Yeah, so to show that I'm excited, just have this. All right, so thank you very much for um, partaking in this particular series of optimal control theory, videos. I appreciate you. See you next time. Okay, wait. I wish you the very best. Whatever exam you are using this to prepare for, I wish you the very best at it. Okay, God bless you and see you next time.